All right, so we just learned that the parent function for a quadratic function is f of x equals x squared. So let's graph that and take a look at some of the characteristics that we have. So we can make a table of values our first time graphing this, and then I'll show you kind of a shortcut for how to graph, but let's just see what happens when you actually do plug in your x values and what you get back for your y values. So we've got our table. If we plug in a -2 for our x, and then we square that, -2 squared is a +4, so that gives us the point -2, 4 on our graph, or on our parabola. So I'm going to go ahead and plot that. From the origin, I'm going to go to the left 2 and up 4, and there's the first point on our parent function. And then we'll just do this for the rest of the ordered pairs. We're going to plug in our x value, so -1, we square that, gives us a +1. That ordered pair is -1, 1. Plot that point. Plug in a 0 for x and square it, just gives you back a 0. So 0, 0. Plug in a +1 and square it, gives us a +1, so we have 1, 1. And then the last point we're going to plug in is a 2. 2 squared is +4, and so that gives us the point 2, 4 on our graph. So we're going to go over 2, up 4, and we can sketch in our parabola. So just a couple things I want to point out from our vocab is, here's your vertex of our parent function is at 0, 0. The axis of symmetry would be the vertical line that goes through the vertex, cutting your parabola in half. And you can see, now that we have specific points, you can see the symmetry of it. So this point 1, 1 is symmetrical to this point over here, -1, 1. We've got this point 2, 4. Its symmetrical point over here is the point -2, 4. So wherever your parabola is with that axis of symmetry, every point on one side of your parabola has a reflection point on the other side. I do not expect you guys to create a table of values every time you have to graph a parabola. So I do want to tell you about, I just call it the 1-3-5 pattern. So let's write in a couple notes. Parabolas have a 1-3-5 pattern. Which helps when graphing. All right, so here's how you would graph something with a 1-3-5 pattern. So from the vertex, follow this rise over run pattern. When I say rise over run, it's going to make you think of slope a little bit, and that's okay. You'll kind of see how it works out. So 1 over 1, 3 over 1, 5 over 1. So there's the 1-3-5 pattern. So from the vertex, you're going to do this first. You're going to go up 1 to the right 1, plot your point. From there, you're going to go up 3 to the right 1, plot your point. And from there, you'll go up 5 to the right 1 and plot your point. So if we just check what we've already graphed, from the vertex, go up 1 to the right 1, there's our parabola. Go up 3, 1, 2, 3 to the right 1, there's your parabola. And then we could have gotten one more point, of course it's off our graph, but 1, 2, 3, 4, 5 to the right 1, and just had more points on our graph. That does give you the right side of your parabola. So to get the left side, instead of going to the right 1, you'll just go to the left. But that's how you'll get those reflection points. You'll go up 1 to the left 1, up 3 to the left 1, up 5 to the left 1. We're going to talk about this in some more examples, and you guys will practice some graphing with it as well. But that's, once you know where your vertex is and you know the pattern, which is based off of the 1-3-5, you can graph these pretty easily. All right, when are the values of f of x positive and when are they negative? So the parent function, f of x equals x squared, will always have positive values. Except at the vertex, when the value of f of x is 0. Okay, so here's what we mean by that. So the parent function, which is just your x squared function, always has positive values. If you notice, the entire parabola is up here where your function is positive. All the y values are positive, except for at the vertex, which is at 0, but your x squared parabola does not go below the x-axis. We could change the equation so it does, and we'll see what that means in some upcoming examples, but the parent function, f of x equals x squared, will have positive values except at 0.